Let's prove this formula by induction, and in order to do that, I'm going to once again apply my first principle of finite induction here, and the first step is going to be to prove that this formula works for what's called the base case, or for the lowest value that we're interested in. So here our base case is 1, and we just plug in 1 to both sides of the equation and make sure that we get an equality. This is pretty direct in this example. Plug in 1 and we get an equality, so this concludes our base case. Now for the inductive step, we're going to take our formula and assume it's true for a value k. So k is some positive integer, it just represents any positive integer. We're going to assume that this is true for k, and then we're going to use that to show that the formula is true for k plus 1. So here I've written the formula with k plus 1 instead of k, and I need to somehow take what's in white and use that to show what's in green here. Looking at this, if I'm assuming what's in white is true, how can I manipulate that to look like what's in green? I see on the left-hand side, I can add k plus 1 cubed, and that will give me the left-hand sides equal to each other. So now that I've added k plus 1 cubed to both sides of what I was assuming, I can essentially try and simplify the right-hand side of this white equation to make it look like the right-hand side of the green. If I've done that, then I've proven that this formula, by our mathematical induction theorem, is true for all positive values of n. And so how do I end up doing this? Well, I see, what am I looking for? I'm always going to keep in mind I'm trying to end up with k plus 1 times k plus 2 divided by 2 all squared. And so what's my first step to get there? Well, I'm going to have to combine these fractions. In order to do this, how about we distribute this square on the first fraction here in preparation to be able to combine these folks. And so here I've distributed my square, and we'll bring it out a little bit more here. And now I get a little bit closer to being able to combine these folks. But before I get too excited, where am I headed? I'm headed towards k plus 1 times k plus 2 divided by 2 all squared. And I actually see where I'm at right now, I can see a k plus 1 squared. So it's not necessarily an obvious thing to factor out this k plus 1 squared, but that's why I got to keep that what's in green always at the forefront of my mind. I'm going to want a k plus 1 squared at the end of the day, so let me just factor that out, and then can I find k plus 2 squared in what's left? And then we'll obviously have to worry about the divisor as well. So let's go ahead and combine these fractions, and when we combine these fractions, well, maybe now you start to see it. Where am I going to find a k plus 2 squared here? Well, I can factor this numerator, and it'll be k plus 2 plus k plus 2, or multiplied by k plus 2, which we more commonly call k plus 2 squared, and all of a sudden, I'm right there. And by the mathematical induction theorem, this proves the formula for all values of n greater than or equal to 1. Make sure to like and subscribe and let me know what you want to learn next.